All right, today we're talking about section 5.3. In section 5.3, we're introduced to some more identities. In section 2, you've got the Pythagorean identities, you got your odd and evens, among others. We had some quotients, etc. Here we are looking at what are called the sum and difference identities, and these are used when you're talking about finding the sine, cosine, or tangent of the sum of two angle measures or the difference of two angle measures, hence their names. Now today we're going to be looking at these diagrams that help produce these identities and where they come from so that we can then use the identities for their actual purpose at a later time. So first things first, we're going to kind of review something for a moment. Let's start with any little right triangle. And in our right triangle, we're going to call this angle, let's call it theta for the moment. The side adjacent to theta we're going to refer to as x, side opposite we said is y, and the hypotenuse we called r. And this is a format that we actually used in the previous chapter. Now if we start to use our just general right triangle trig information, then the cosine of angle theta is equal to the adjacent over the hypotenuse, x over r, and the sine of angle theta would be equal to y over r, the opposite over the hypotenuse. Let's kind of multiply here. I'm going to multiply both sides by r. So r times the cosine of angle theta gives us the length x, and r times the sine of angle theta gives us the length y. So what does that mean? It means that for any triangle, given the length of the hypotenuse, what we called r in this case, and the measure of an angle, the acute angle specifically, then we can determine the length of the side adjacent to that acute angle by multiplying the length of the hypotenuse, r, times the cosine of the acute angle. And we can find the length of the leg opposite that acute angle by multiplying the length of the hypotenuse times the sine of the angle. And that's going to come in handy when it comes to setting up our diagrams for the sum and difference identities. So now let's look at what our identities are going to look like in this section. And what we're going to start off with is adding two angle measures. So the way that we want to do that, we're going to give ourselves a triangle to start off with, a right triangle specifically. Doesn't matter how large you make this, but nonetheless, we have a right triangle and we're going to refer to one of the acute angles as A. All right, now I want to add an angle to that, and I'm going to do that up here above this hypotenuse. And the way that we're going to do that is by taking this point, and along this hypotenuse here, that hypotenuse is going to become a leg of one of our second right triangle. I'm going to draw another right angle here, and we're creating a second right triangle such that the leg of the second triangle is the hypotenuse of the first. And we're going to call this angle B. In this case, we're going to let the length of the hypotenuse in the triangle with acute angle B, we're going to let that hypotenuse have a length of 1. Okay, so what I want to then determine is the lengths of these other segments in terms of A and B. So when the hypotenuse is 1, remember the length of the leg adjacent to the acute angle is the length of the hypotenuse times the cosine of the angle. So in that case, the length of this leg adjacent to angle B with hypotenuse of 1 times the cosine of B would produce the cosine of B. And for the length of the side opposite the angle, it's the length of the hypotenuse times the sine of the angle. In this case, 1 times the sine of B would just be the sine of B. Okay, now let's jump into the other triangle, the triangle with acute angle A. Here again, the length of the side adjacent to the angle is the length of the hypotenuse times the cosine of the angle. So in that case, that would be the cosine of B, the length of the hypotenuse, times the cosine of the angle, which in this case is angle A. Likewise, the length of the side opposite it would be the length of the hypotenuse times the sine of the angle, sine A. what we've now created are just the side lengths of those two triangles based on the angle A and angle B that we were given. Okay, next thing we want to do, we're going to create a rectangle surrounding this diagram, and the way that we do that is by extending this side up, and I'm only going to extend it far enough that the top here is even with the top of this point on the triangle. So I'm making it the same height. In that case, same thing over here. I'm going to be perpendicular in each case. So I'm making a right angle in this position, like so. So all three of these here create a right angle. Likewise, we're going to create a line perpendicular to both of those vertical segments all the way across the top. Okay, so we've created this rectangle then. We've got a right angle here, got a right angle there as well. And we've got some angles that we can look at. Okay, so first things first. Remember, we're talking about angle sums and differences. Consider this angle here that's the sum of angles A and B together. Given the fact that this is a rectangle, and we know that means this segment across the top and this segment across the bottom are parallel, then that means this angle would also have a measure of A plus B. So this angle is A plus B, the alternate interior to the one below. Other angles that we can identify in this diagram, let's deal with this little triangle up here. What we need to have eventually is the lengths of all of these little segments in these right triangles in terms of A and B, or the sum A plus B. Okay, so let's consider this little triangle up here for a moment. We know that these three angles surrounding this point have to be supplementary. They have to total 180 degrees. We also know that this angle is already a right angle, which means these two acute angles have to be complements. Consider this triangle. A is a complement to that angle. So if this angle is a complement to A, and it's a complement to this acute angle here, then that implies this acute angle has to also be A. So this angle right here is A. Okay, so we're going back to these relationships now that we've got an acute angle in each triangle identified. So we want to determine the lengths of the sides based on the length of the hypotenuse times the cosine of the angle, that'll give us the adjacent leg, and the length of the hypotenuse times the sine of the angle, that gives us the length of the opposite leg. Okay, so let's deal with this smaller triangle first. With this acute angle A, the side adjacent to it, which is from this point up to that right angle, the side adjacent to that acute angle would be the length of the hypotenuse times the cosine of the angle. So this little segment right here would be the length of the hypotenuse, sine B, times the cosine of the angle, cosine A. Also in that little right triangle, this segment is opposite angle A, which means its length will be the length of the hypotenuse times the sine of the angle. So this segment is the length of the hypotenuse, sine beta, times the sine of the angle, A. Okay, so we've identified the lengths of the legs in this smaller right triangle. Now let's use this larger right triangle. Now in the case of this larger right triangle here, we have our acute angle measure as A plus B. Okay, so let's deal with the side adjacent to that angle A plus B. The length of the side adjacent to the angle is the length of the hypotenuse times the cosine of the angle. Now in this larger right triangle, the length of the hypotenuse is 1. So when we multiply the length of the hypotenuse times the cosine of the angle, here this length produces the cosine of, and we write this, since it's a sum, we write it in parentheses, the cosine of the quantity A plus B. Likewise, the side opposite that angle is the length of the hypotenuse times the sine of the angle. So the length of the hypotenuse, 1, times the sine of the angle, produces the sine of the sum A plus B. Okay, so we've got every side identified in this case. Now let's look at what's actually going on. We know since this overlying shape is a rectangle, that in a rectangle, the sides that are opposite one another have the same length, which means in this case, two things are going to be true. Consider these two vertical sides. This side, the sine of A plus B, would have to be equal to the length of this side. Now this side's broken up into two parts. It's got this part, the sine of B cosine A, and this part, the cosine of B times the sine of A. And I'm going to rewrite this, but I'm going to write this one first. I want to write the sine of A first. It's not wrong to have it the other way. If you wrote it as this form, cosine B sine A, that would also be okay. And we're going to add that to the sine of B times the cosine of A. And what that does is it creates one of the sum and difference identities from this section. This is the sine sum formula. So the sine of the sum of two angle measures is the sine of the first angle measure times the cosine of the second angle plus the sine of the second angle times the cosine of the first. So keep in mind the order in which things are happening here. Here we have the sine of A, there's our A, and here's our A. And our B, cosine B, and sine B. Which just means that whenever I go to substitute in different angle measures, maybe a pi over 3 and a pi over 4, that whatever I place here needs to go in both of these positions, and whatever angle I place in this position is going to appear in both of these positions. But that's our sine sum formula. All right, so that we get from looking at the left and right sides of this rectangle. Now let's talk about what we get when we look at the top and the bottom. So on the top, we have two parts being added together. We have the cosine of the quantity A plus B is added to the sine of A times the sine of B. And there again, I rearranged the terms, they're not the terms, but rearranged the two parts of that product. But if you wrote it as sine B, sine A, it would be fine. And that would be equal to what we have here on the bottom. And there again, I'm going to reverse cosine A, cosine B. Products are commutative, so it doesn't matter which order you wrote that in. Okay, so we typically don't see this one in this form. We usually see it with this cosine of the quantity A plus B isolated. So the way that we'd isolate that in this case would be to subtract this quantity on both sides, which would produce this quantity, cosine A, cosine B, minus that quantity, sine A, sine B. And that produces what's known as the cosine sum formula. So this is our sine sum, and this is our cosine sum. Now look at the difference between the sine sum and the cosine sum. Remember here we had the sine of A plus B gave us the sine of A times the cosine of B, where we're multiplying a sine and a cosine together. Different angles, but still multiplying the sine of A times the cosine of B. Notice the difference here with the cosine sum. When you're doing the sum for a cosine function, you take the cosine of the first angle times the cosine of the second angle, both cosines, and we subtract from that the sine of the first times the sine of the second. So in the sine sum, you're going to have a product of sine and cosine, a product of sine and cosine, whereas in the cosine sum, you have the two cosines together and the sines together, and the cosines always go first in this position. Okay, so what we've identified then are the sine sum and the cosine sum. In the next video, we're going to talk about how we take those and create the cosine difference and the sine difference, as well as the identities for tangent.